So if we're going to solve by completing the square, we first wanted to get a single x squared, and we have 3x squareds. So we would have to divide by 3. Now what makes this one not as nice as some other ones is dividing by 3. Well, that works out nicely to give me x squared. But what happens when I divide the 5 by 3? I get a fraction. And if I leave my space already, draw my equal sign and put my 7 on the other side, it gets divided by 3. Oh, I have fractions. Not the end of the world, but not as nice when the numbers are nicer. Next, we'll have to complete the square. Well, to get an x squared, this is going to be an x. That makes sense. Ooh, but mental math-wise, that negative 5 over 3 is actually worse than normal, right? Because it's a fraction. But if you think about a pattern that you've noticed, how do we go from here to here? We notice the pattern that every single time we're cutting it in half. So if I take negative 5 over 3 and multiply it by a half, I get negative 5 over 6. Then moving up to this number, what number goes in that space if you actually squared it out? Do you see that your last term would be negative 5 over 6 times negative 5 over 6, or negative 5 over 6 squared? So I'm going to square negative 25 over 6. It's going to be positive. 5 times 5 is 25. 6 times 6 is 36. So if I add 25, 36 to one side, I have to add 25, 36 to the other side. And also not the most wonderful thing in the world, but how do you add fractions? You would need a common denominator. So I would get a common denominator of 36, which will change my 7/3 to 84 over 36 plus 25 over 36 gives me 109 over 36. So when the numbers are not nice, it just means you have more fraction work to do. But now that you're in grade 11, you have been doing fractions since middle school. They should be more annoying because they take longer, but not necessarily hard. The math that we're going to be doing this year is a lot harder than the rules for fractions. Fractions were the hardest thing you learned in middle school, but now it's actually, the rules aren't that hard. You just need to do them. It's annoying, yes, but not necessarily hard. Next, in completing the square, we would square root both sides. So if I square rooted this side, I get x minus 5 over 6, and I have to remember when I square root this side, I have plus or minus. I can square root the top, 109, and I can square root the bottom, but what's nice about square rooting the bottom? Square root of 36 works out nicely to just be 6. And finally, I can add 5 over 6 to both sides. Now we already have a common denominator, which was really nice. We write our final answer as a single fraction. I'm just going to make that a little bit smaller, so I'm going to zoom out so we see everything. I'm going to highlight our solution here. Oops. There we go. Group it together. Just make it a little bit smaller off to the side. Perfect. So mathematicians would say, if you can do it with 3, 5, and 7, do you think you could do it if I changed the numbers to 4, 7, and 8? Or 6, 9, and negative 2? Could you do it with any numbers I throw up there? Right? It just would take time and be, right? So what mathematicians do next is they say, if you could do it with any numbers, maybe we could make a formula. And if we wanted to make a formula, we would have to do it with any numbers. So instead of a 3, I pick a letter and say A. Instead of a -5, I pick I'll go B. And then I'll go C, and I'll make it equal to 0. And A, B, and C can be any numbers we want. Could we do the same process in algebra if we use letters instead of numbers? And that's why I did it first with numbers, the hardest ones I could think of. Because now we're going to work parallel, and we're sort of going to use our numbers as a hint. What did we do first? We divided by 3. So what should we do if it was an A? Divide by A. So I'm going to divide everything by A. That gives me x squared. You see that this would make a fraction, B over A. Then I left a space, and C would get divided by A as well, and then I leave a space there as well. Oh, when I move the C over, I have to be careful. Erase that. It's going to be a -C, so I'll just write that nicer. When I move the C over, it would be subtracted, and I would get -C. So in the same way we divide by 3, we divide by A. Okay, next, we set up our squared. Well, the x squared, that's super easy. That's going to have to be an x to start with. But then this is where that pattern really helps us. What do we always do to the middle number? We always have divided it by 2. So if I do that here, dividing by 2 is the same as multiplying by a half. Multiplying by a half will just give me a 2a in my denominator. And then I need to fill in this space. Well, whatever number is there is going to get squared. So in the space, I would have a b squared over a 4a squared. And if I add b squared plus 4a squared on that side, I need to add b squared over 4a squared on this side. What did we do with our fractions? We got a common denominator and added them. What do I need to do with these fractions? I need to get a common denominator and add them. Can you see that the common denominator is going to be a 4a squared? So I'd have to multiply the top and the bottom by 4a. Then I would have a common denominator of 4a squared. And the top, if I add it together, I could either write it as -4ac plus b squared, or I could write it as b squared minus 4ac. And that's the way it's written most often, with the b squared first. Okay? What did we do next in our numbers? Square rooted both sides. What are we going to do next with our letters? Square root both sides. So this side will be b plus 2 over a, and this side will be plus or minus. The top will get squared, b squared minus 4ac. The bottom will get squared, and the square root of 4 is just 2, and the square root of a squared is just 8. Then we could get x by itself by moving. I can move the b over 2a over to the other side. And I already have a common denominator. And this is one of the most famous formulas you learn in high school. A squared plus B squared equals C squared. Like famous formula number 1, I would probably put this one like famous formula number 2 that you learned in high school. What does this mean? Well, let's look at the question we just did with completing the squares with numbers. We had, I'll do it in purple, 3x squared minus 5x minus 7 equals 0. The formula says, well, anytime you want to solve this, if you write it as a, b, c equals 0, because that's how we started, then you can say the answer is going to be negative b. Well, my b value is negative 5, plus or minus. Negative 5 squared, well, a negative times negative, that'll be positive 25, minus 4. My a value is 3. My c value is negative 7, all over 2 times a. And if I simplify this, negative, negative, that'll be positive 5 plus or minus 25 plus 84, 109 over 2 times 3, 6. And wow, was that not a lot faster than completing the square with a whole lot less mental math to be done? A formula is very powerful, almost too powerful, because you guys are going to disappoint me. I'm just letting you know. I'm going to get disappointed because you're going to like the formula so much, you're going to stop completing the square, and some of you will forget how to do it and make mistakes on it when we get to quizzes and tests. And I'll say, solve by completing the square, and you're like, oh, I forgot, because I only use the formula. But the only reason we can use the formula is because we know how to make it with completing the square. So you now have 3 different ways to solve a quadratic equation. The first way we learned was by factoring. That is always the fastest if you can factor. It's not fast if you can't factor. Then it's back. Okay? This is our class. We have to pause the video. This is important. So with that in mind, we can go to example 1. And we have those 3 strategies: by factoring, by completing the square, or by formula. And they all have certain places where one is better than the other. For part A, I'm going to tell you the formula is, well, we'll do A and B. These are designed for us to do the formula. We'll do the formula, but I'll actually show you in B that completing the square is perhaps slightly better. And you'll see why when we get it. But in A, if you would, first of all, check to see if you could factor it, it is not factorable. You have to get really good at checking factoring to say, hey, I should always check factoring first. And if it doesn't factor, then maybe I go to completing the square or the quadratic formula. So if we go to the quadratic formula, which I'll write up here again, negative b plus or minus b squared minus 4ac all divided by 2a. You need to have your equation written equal to 0, just like for factoring. Then whatever's in front of your x squared, that's your a value. Whatever is in front of your x is your b value, and whatever's in front of your, well, nothing. Whatever's just the number, your constant, is your c value. And we can take this and plug everything in. So we would have negative b. Well, my b value is 2, so I'd have negative 2 plus or minus. B squared, 2 squared is 4, minus 4 times a was 1, times c is 7, over 2 times 1. Negative 2 plus or minus 4 minus 28 is negative 24, and 2 times 1 is 2. And some of you, this will be the happiest moment for you, because this is the easiest question that there is. What can you do with the square root of negative 24? You can't. Can you square root negative numbers? immediately tells you not possible, which immediately tells you the answer to this question is there is no answer. There is no solution. It is unsolvable. And the quadratic formula told us that to us right away. As soon as you get a negative inside that square root, you are like, happy dance, no more math for me, no solution, not possible. You'll see at the bottom of the page, the textbook is really formal. They write no real roots. Because technically, if we're allowed to use imaginary numbers, we can solve this. You ever heard of imaginary numbers? It's like the math teacher's gone crazy. Like, with real numbers, not possible. But imaginary? Yeah. Sure. Does anybody know the famous imaginary number I? Yeah. Famous imaginary number I says, well, if you imagine you're allowed to square root the -1, then we can do a whole bunch of math with imaginary numbers. That's the famous imaginary number, but we don't have to do imaginary numbers in grade 11. They used to have it, but they took it out. So, as soon as you see a square root of a negative number, you would just write not possible, and you're all done. So let's look at B. Going to my quadratic formula, I would have negative 2, which would be positive 2, plus or minus negative 2 squared. Negative times negative is always positive, so that'll be 4, minus 4a is still 1, but c is negative 7 this time, divided by 2 times a. And so once again, the quadratic formula gets us the answer really quickly, but this time I have the square root of 32 divided by 2. This is the right answer, but it will not give you full marks on a quiz or a test because it's not simplified. Can you simplify the square root of 32? Yes. The biggest square root that divides it is 16. So you would have to write this as 4 root 2, part of your root 2 family, 4 root 2 over 2. And that is also the right answer, and is more simplified than the first answer, but you would still not get full marks because it's not completely simplified. You're dividing by 2. Do all the numbers on the top divide by 2? No. They do. So you would have to, 2 divided by 2 is 1. 4 divided by 2 is 2. This is your simplified final answer. The completing the square in this situation, I'm just going to do it right beside. I had x squared minus 2x. I would leave a space. I would move my 7 over to the other side and leave a space. If I use the completing the square method, first of all, the 2 kind of says that's not a not nice number. I'm not going to have fractions with the 2. So it's really easy to see this has to be x minus 1, which means I'd have a plus 1 here and a plus 1 here, giving me 8. I square root both sides. I get plus or minus the square root of 8. And I get x by itself by moving the 1 over. I still have to simplify the 8 to 2 root 2. But in this situation, I think that completing the square, it's still slower to get the answer. Okay? We got the answer, the correct answer in one step with the formula. But it's quicker to simplify sometimes. So it's like half and half. Yes.
How can you tell which one you should use?
I usually look at, is there an a value? Like these ones had a values of 1. So I don't need to divide by the a value. That's one check mark for that I would say maybe I should use completing the square. Second thing, is that an even number? Because Because I have to divide it by 2 when I complete the square, right? This step here, this always divides by 2. If it's an even number, I know that that works out nicely. If it's an odd number, I know I'll have fractions. So those would be the 2 things. Even number in that b value, so that I don't have fractions, and an a value that's not there, might make me go towards completing the square. However, you have to get good at simplifying anyways, so it's not bad that we had to simplify. But that would be when I could tell that completing the square would be the faster way. B value is even, a value is 1. You're not worried about fractions, not worried about bigger numbers. Questions for practice? Circle 4, 5, and 6.